Everyone, welcome to your play posit for the week, the very first play posit of semester 2. We are going to be finishing up just a little bit from our notes in live class yesterday, and then we're going to get into the Pythagorean theorem, one of the theorems that you guys hopefully will feel is familiar and similar. You've learned it before. We're going to again take it just one step further in geometry when we look at how it relates also to the area formula. So let me grab my pencil tool. One of the things that we were looking at in class was this problem. Now remember, when we have parallel lines here, a bunch of proportions are available, not just the traditional ones that you think of. And this is because of the triangle proportionality theorem. So we talked about how you can do like part over part, x over 15 equals part over part, 4 over 10, right? That's one proportion we could set up. Let me make sure my pen is working. Yep, okay. Another way you could do it is you could do part over the whole thing. So the whole thing is 15 plus x, and then part 4 over the whole thing, 4 over 14. And then even another one of my students said, well, hey, can't you do like the top part over the top part? Well, I say top, this is this is more the bottom, isn't it? Bottom over the bottom, and the bottom, this piece over this piece. So we did 10 over 15 and 4 over x. Now, because the triangles are similar and we know that this is proportionality theorem holds true, all three of these should give us the same answer. So let's see. We'll do 10 times x equals 15 times 4. And don't forget, you can use your Desmos calculator. So 15 times 4 is 60. And this is 10 times x. So remember, the inverse of multiplication is division. So we'll divide both sides by 10. And x is 6. All right, let's try the red one. 10 times x. And, 15 times 4. So you can see we get the same equation here. 10x equals 60, so x is 6. It's looking promising. Let's try this one. 14 times x, and then 4 times all of this. Remember, when you have a statement like this with more than one term, an expression, you need to multiply this number by everything. We have to distribute it. So I'll just rewrite this. So we're going to do 4 times 15, that's our 60, and 4 times x. All right, and we're going to solve for x, right? We'll combine our x terms, subtract 4x from both sides, and you get 10x equals 60. Divide both sides by 10, and sure enough, you get x equals 6. So in all cases, you get the same answer, and that's kind of because of the beauty or the magic or the mathematics behind it, because the triangles are similar and that proportionality theorem is true. So that's pretty cool. Another reason why you guys can choose the way that you see it first, the way your brain processes it first, and do it that way. Before we move on, I just want to say, have you guys noticed how much better my handwriting is in videos than in live class? Look at this. And I'm using the same pen. So I think New Row has some funky handwriting things going on. Maybe I can put a ticket in for that. I feel like it's so much nicer on this screen. I mean, you can see this writing is from class. I took a snip, and then here's my writing from today. Way better. All right, let's get into the Pythagorean theorem. The Pythagorean theorem says, given any right triangle, this is true. You take the side and you square it. You add it to the other side and you square it. And that always equals the hypotenuse squared. Remember, the side across from the right angle is called the hypotenuse. Always. We're going to use this word a lot in class. It's always the longest side as well. Doesn't really matter which one of the legs you use as A and which one is B, because we're just going to add them together. So that's it. This is the Pythagorean theorem. This is on your formula sheet. It's written a little bit differently. I'll show you guys that next class, but it is there. And so let's try it. I'll write the theorem up here. And we said A is 3, B is 4, and C is, we don't know. So we're going to do 3 squared. We're just plugging it in. Plus 4 squared equals C squared. So again, you can use that calculator. 3 squared. Remember, the little exponent means to write it twice. We learned that in algebra. So this is 4 times 4. That's what the squared means, to write it twice. So 3 times 3 is 9, and 4 times 4 is 16. 9 plus 16 is 25. And do you guys remember how to solve a squared? How do we get rid of the squared? We have to think, well, what's the inverse of squaring? Or what's the opposite of squaring? And it is square rooting. So we're going to square root both sides. When you square root a squared, they cancel out. And that's because, remember, this means we're writing it twice, right? And when you have two things, if you had me in class last year, this is how we did it. You want to find pairs of things. When you find a pair of things in a square root, it comes outside. That's why we're able to get rid of that squared. Same here, 25. Again, you can use your calculator, but we know 25 is a perfect square. It's 5 times 5. There's our pair, so we can take it out. C equals 5. 3, 4, 5 is actually a special right triangle. It's called a Pythagorean triple. Pythagorean triple. So literally every time you see 3 and 4, you know it's going to be 5. If you see a 5 here and you have a 3 here, you know it's going to be 4. It's a special Pythagorean triple. You see it a lot in architecture and building and art. So there are a bunch of Pythagorean triples. You guys should look up some. We'll talk a little bit more about those. They're just kind of special, but they're also easy to remember. So let's try it. Find the missing side of each triangle. Remember, if I don't build in a pause for you, you can pause this recording at any time. The big thing to remember is that you want the hypotenuse always on the right-hand side. The hypotenuse is across from the right angle. So this is always going to be what's on the right-hand side of the equation. So here we're going to have 12 squared plus x squared equals 13 squared. And we're just going to solve. So 12 squared is 144. Oops. And 13 squared, I believe, is 169 if I remember correctly, but I'm going to grab my calculator. Yep, it is. And we're just going to keep getting the x by itself, so we'll subtract the 144 from both sides. We get 25. Now remember, to get rid of a squared, to get this x all by itself, we're going to do the inverse, which is square rooting. So square root of 25 is 5. Now something I haven't mentioned yet. Remember from algebra, when you take the square root of a number, you actually have two answers, right? You have a positive and a negative. And that's because, look, 5 times 5 is 25, right? There's that square root. But also, negative 5 times negative 5 is 25. There's that square root, those two matching numbers. So whenever you take the square root of a number, you always have two answers, the positive and the negative. But when we're talking about the length of a side of a triangle, are we ever going to have negative length or a negative measurement? No, right? This is inches. So we're always going to have that positive answer. Let's try this one. Oh, do we even have to try it though? Look, 3, 4, we know this is going to be 5. We can do it though if you want. 4 squared is 16, 3 squared is 9. There's that 25. X is 5. That's that 3, 4, 5 Pythagorean triple. All right, let's try this one. Here's the hypotenuse. So remember, this is always our C value. So we'll have 11.9 squared plus x squared equals 14.7 squared. Decimals are totally fine. They're actually more realistic than no decimals. You typically have decimals in real life. Of course, this is real life. 141.61, I definitely used my calculator. 14.7 times 14.7 is 211.68. We're just going to subtract this from both sides. You can see that the process is the same. It's going to start to feel like you're going to be doing it in your sleep. Hopefully not, but maybe. And you get 70.07. Now we'll take the square root of both sides. And you get x equals 8.4 kilometers. Oops, I forgot my units up here, miles. This is another place to keep an eye out for those units and make sure that they don't try to trip you up and give you two different units in one diagram. If they do, just make sure that you convert whichever one you want and so they're the same units. All right, let's get another color. Here's our hypotenuse. This one's going to be very similar. The leg squared plus the leg squared equals the hypotenuse squared. So let's see, what is 6.3 squared? That's 39.69. And 15.4 times 15.4, 237.16. We're going to subtract this from both sides. I'm going pretty fast. I hope I don't make a mistake. I'll try to slow down. Sometimes when I go too fast, I make those silly mistakes, you know? I know that you guys can relate. It happens. We're all human. But I'll slow down a little. There we go. Okay. Now we're going to take the square root of both sides. Oops. My calculator has a mind of its own. No. There we go. X equals 14.1 miles. All right, so this was just kind of practicing using this Pythagorean theorem, making sure you identified the hypotenuse. That's the one that always goes on the right-hand side of the equal sign. So here's sort of, you know, more of an application problem. We have a plane that's coming in for a landing, and we're going to find the missing length. So pilots, they certainly don't sit there and calculate anything using the Pythagorean theorem, but the programs that they use a ton of mathematics, algebra, geometry, the distance formula, the Pythagorean theorem, systems of equations. Have I ever shared with you guys how systems of equations are used in flight paths? So that way airplanes obviously do not crash, right? Their line of flight does not intersect with another airline's line of flight at the same exact time. That's a system of equations. So math is used a ton in airline flight. So let's try to find this missing length. We see, actually, we should have this written as a right angle. So we know that we can use the Pythagorean theorem. This is that hypotenuse, C. So we just have some rather large numbers that we're going to square, which means they're going to just get bigger. So hang tight. I'm going to write it all out. Wow, okay. There we go, 1.6. Okay, and we're going to add these two numbers together. This is looking promising, especially this 2,5 in the beginning, right? And then to solve for C, remember you just take the square root of both sides. Of course, my calculator does not like that. It is 50,000 feet. And you may have already solved this before having to do any of this, because you can notice it is a 3, 4, 5 triangle. Isn't that cool? So you could have just went straight for the 50,000. All right, here's another one. My stepdad is a retired fire chief who is now back in the fire service in Louisa County, in Southern Virginia. Is that Southern Virginia? No, they live in Orange and he works in Louisa, if you're familiar with Louisa. And I was talking with him about this last year and then also just every year when it comes up. But in the fire service, they actually literally use the Pythagorean theorem. And I about lost it. Because I was like, okay, in a lot of professions, you hear about calculations that are put into different computer programs or put into different procedures and devices and things like that. But he was like, no, we actually do it. Like they actually calculate it. And they have, so here's an example. Like if there was this building was on fire, he said that they come up with a truck that has multiple different ladders on it, and they have a bunch. They have 25-foot ladders, 50-foot ladders, 100-foot ladders. They have the ladder truck where the ladder like extends from the fire truck. So they have all these different length ladders, and depending on the location, he used to work in Alexandria City before Louisa. So a lot of those row houses were like all the same height, but in more residential single family homes, they can be all different heights. And so he said that sometimes there's like standard heights for different buildings, so they would actually know the X value, and it would help them find the length of the ladder that they would need to grab off of the truck. This distance here is a standard distance as well. Like he said that depending on the length of the ladder, it tells you how far away you need to be from the building to have a safe climbing angle. So again, we talked for hours about this and I about lost it, you guys. I was like, oh my gosh, I have to tell everybody that I know, mostly my students. I just thought it was really cool that something we're studying, like literally we're studying it, is actually used in a profession in firefighting service. So I thought that was super cool that I wanted to share with you. So let's go ahead. This one's set up a little bit differently here. We know the length of the ladder, and we're going to see how high is this second story building, this X value. So this is the hypotenuse, right? So we're going to have X squared plus 5 squared equals 13 squared. We know 5 squared is 5 times 5, it's 25. 13 squared is 13 times 13, which is 169, right? And then we're going to subtract 25 from both sides, and you get 144. And to get rid of this squared, we square root both sides. X equals 12. 12 feet. There we go. See, it wasn't too hard, and they certainly have phones that have calculators on them, so I don't think they do these calculations in their head. I'll have to ask them about that. So this formula is on your formula sheet. It's also a formula you've seen before. It's finding the area of a triangle. You take 1/2 and you multiply it by the base, and then you multiply it by the height. Remember, we talked about the height of a triangle being the length from the point to the base. So sometimes you could have a triangle drawn like this, and this would be your height right here. So it just kind of depends how it's drawn. This is on your formula sheet, so I wanted to make sure to point that out. The formula sheet you can use on any quiz or test in our class, anyone, and then also on your SOL at the end of the year. So let's try it. Area is 1/2 base times height. And in this case, they give you the area, and they give you the height, and they want you to find the base. So that looks like an 18, yeah. So we're going to fill in what we know. We know area is 180. We don't know the base, and the height is 18. So this just goes back to like old school algebra, right? We're going to solve to get b by itself by dividing both sides by 18. So B is 10. Forget to put in the 1/2 here. I forgot that at first. 1/2. So to get B by itself, we actually have to get rid of this 1/2 as well. So we're going to multiply both sides by 2. Whoops. So B is 20. We can always test this out. We could say, okay, area equals 1/2. The base we said was 20 and the height was 18. Let's see if we do in fact get 180. So 18 times 20 is 360. 360 times 1/2 is 180, sure enough. So you can always double check your work. Don't forget that 1/2 there like I almost did. Let's do this one. Now they want us to find the height. So let's fill in what we know. I'm going to write the formula here. We know the area is 25, and we know the base is 5. And we want to find h. So we have 25. If you want, we can combine these, right? 1 times 5 is 5. 2 times 1 is 2. And now to get rid of a fraction, kind of like we did over here, because I could have put it on over 1, we're going to multiply by the reciprocal. You flip it. Both sides. When you do that, it gets rid of this fraction, right? Because these divide out and these divide out. So now we have 2 times 25. You can put this over 1. That'll help you multiply it. So that's 50 over 5, which is 10. H is 10. All right, last problem. The area of a right triangle is 210 square inches. Or anytime you see square inches, it means literally the same thing as inches squared. Square feet is the same as feet squared. It's just another way to write it. This is like the way to write it using words, and this is the way to write it using symbols. The height of the triangle is 35 inches. What is the length of the hypotenuse? So let's draw a triangle, a right triangle. And it tells us the height is 35, and it wants to know the hypotenuse. Well, in order to find the hypotenuse, we're going to need the other leg of this triangle. But all we have is the area. So let's use what we have. We know area is 1/2 base times height, right? So we're going to plug in what we know. We know the area is 210. We don't know the base, and we know the height. Oh, look, we can find the base by solving for b. And once we have the base, we will have enough information to solve for the hypotenuse. So let's solve for the base. We're going to have 210 equals 35 over 2 times b. All I did was combine these numbers, right? Now we're going to multiply both sides by the reciprocal of the fraction to divide these out. And let's see, 2 times 210 equals 420 over 35, right? 35 times 1. So what is 420 divided by 35? That is 12. So the base is 12. Step 1 is done. We used the area to help us find that missing side length. Now let's use these two numbers to find the hypotenuse. Because it's a right triangle, this is a good big clue. Whenever you see right triangle, you want to think Pythagorean Theorem. So we're going to do 35 squared plus 12 squared equals, we don't know. You could call it C, you could call it X, whatever you want. So 35 squared is 1225 plus 144. You get 1369. So we'll take the square root of both sides. And C is 37. 37 what? 37 inches. We found the hypotenuse. This was kind of a challenge because it was that multi-step problem, right? We had to use what we were given. We were given the area, solve for the missing leg, and then use the Pythagorean theorem to find the hypotenuse, what it wanted in the end. So I look forward to seeing you guys in class next week. I truly cannot believe how fast this semester is like already moving, you know. Please reach out if you have any questions at all, and I will see you guys soon. Bye, everybody.